We're on Unit 9, Lesson 2. This is about zero and negative exponents. And we're going to use the property of exponents to simplify powers that have positive, zero, and negative exponents. Okay? So let's go ahead and move on and get started. First thing I want to talk about is let's look for a pattern for what happens when we're dealing with exponents here. So in this first row here, 2 to the n power, okay? So up here is where I'm talking about the power. So 2 to the third power means 2 times 2 times 2, that's 8. 2 to the second power is 4, and 2 to the first power is 2. Okay, so as we go down this table, let's look for the pattern, what's happening in each of these different columns. Well, I get from 8 to 4 by dividing by 2. And I get from 4 to 2 by dividing by 2. So to get to the 0 power, I'm going to divide by 2. And 2 divided by 2 is 1. Then to get to the negative first power, I need to take 1 divided by 2, which is 1/2. Then I will take 1/2 divided by 2 and get 1/4. And take 1/4 divided by 2 and get 1/8. So look at the pattern here when we go down by 2. Okay, so 2 to the 0 power is 1. Okay? And 2 to the negative first power is 1/2. And 2 to the negative second is 1/4. Okay, so let's look and see how this pattern goes throughout other numbers. So here, 3 to the third power is 27, 3 to the second is 9, 3 to the first is 3, so we're dividing by 3 every single time. So 3 divided by 3 would be 1, 1 divided by 3 is 1/3, and then 1/3 divided by 3 is 1/9, and then 1/9 divided by 3 is 1/27. If we do 4, okay, 4 to the third is 64. If we do 4 to the second, that's 16, and 4 to the first is 4. And we're dividing by 4 each time. So 4 divided by 4 is 1. 1 divided by 4 is 1/4. 1/4 divided by 4 is 1/16. And then the next one is 1 over 64. 1/16 divided by 4. So let's look at the patterns here. Look at these columns right here first of all. 2 to the 0 power is 1. 3 to the 0 power is 1. 4 to the 0 power is 1. So anything raised to the 0 power is 1. And it says, how can you evaluate an expression as a negative exponent? Well, let's look at the commonalities here between the positive versions of the exponent and the negatives. Let's look at squareds, for example. Okay, 2 squared is 4, and 2 to the negative second is 1 to the fourth. Those numbers are reciprocals of each other. 3 squared is 9, and 3 to the negative 2 is 1/9. Again, reciprocals. 4 squared is 16, 4 to the negative second is 1/16. Again, reciprocals. And that works if we look at the 3 columns. Okay, 2 to the third is 8, 2 to the negative third is 1/8. 2 to the first is 2, 2 to the negative first is 1/2. So, a negative exponent is the reciprocal of the positive exponent. Okay, so basically to evaluate a negative exponent, we just take the value of the positive exponent and flip it over. So 2 to the third is the same as 1 over 2 to the third. Or sorry, 2 to the negative third is the same as 1 over 2 to the positive third. Okay, so example. 2 to the negative third is the same as 1 over 2 to the positive third. So it's the same as 1 over 8. Okay? So that's the relationship between exponents with 0 and negative exponents. So let's go on to the next slide here. And here are the definitions. The definition of a 0 exponent: any non-zero number raised to the 0 power is equal to 1. So for example, 1 to the 0 equals 1. 2 to the 0 equals 1. 1/4 to the 0 equals 1. Negative 5 to the 0 equals, you guessed it, 1. Okay, any non-zero number to the 0 power equals 1. Now, the definition of negative exponents: any non-zero number raised to a negative power is equal to the reciprocal of that number raised to a positive power. So 3 to the negative second is the same as 1 over 3 to the positive second. 3 to the negative x is the same as 1 over 3 to the x. 3 to the negative first is the same as 1 over 3 to the first, and so on. Okay? So that's how negative exponents and zero exponents work. Let's evaluate this or explore this a little more. So let's look at what happened when we extend this pattern and use 0. Well, 0 to the third power means 0 times 0 times 0, that's 0. 0 to the second power is 0 times 0, which is 0. 0 to the first power, that's just 1 0, which is 0. Okay? Now let's look at what happens here. Remember, let's look at the pattern here. We've got anything to the 0 power is 1, but we've got 0 to anything, it looks like, is 0. So, 0 to the 0 power is either 1 or 0. It's kind of undefined. Okay? And it depends on, different mathematicians will tell you different things. Some of them will say it's 1, some of them will say it's 0. So, it can be 0 or 1, depending. Now remember our definition of a negative exponent. That's where we're going to take the number and find its reciprocal. So 0 to the negative first power, by definition, should be 1 over 0 to the 1. Well, the problem is 0 to the 1 is 0, and we know we can't divide by 0. Okay? So these are undefined. We cannot have 0 raised to a negative exponent. Okay, that is not possible. It's undefined. So I should cancel out, 0 or undefined here. Because what I meant by undefined was just, it can be either one. People haven't decided on which one it actually is. It depends on who you talk to. Okay? Whereas this one doesn't have an answer. It's undefined. So 0 to a negative exponent, not possible. 0 to the 0 power is either 0 or 1. Now let's do some more problems with these. Okay, here we want to rewrite with positive exponents. Okay, so we have to think about what already has positive exponents and what has negative exponents. Okay, well this 5 is really like 5 to the first. Okay, so that's a positive exponent, so this is really like 5 times 2 to the negative x power. Well, remember what we said about when we have a negative exponent and we want to make it a positive exponent. We are going to change anything with a negative exponent to its reciprocal. Well, the 5 doesn't have a negative exponent, so that stays. Times, and we're going to change 2 to the negative x to the reciprocal, which is 1 over 2, and then the x becomes positive. So it's 2 to the positive x. And now we're just going to multiply these things together. Okay, so 5 is the same as 5 over 1. So on top we got 5 times 1, which is 5. And on bottom, we'd have 1 times 2 over x. And we cannot simplify the numbers, so we are done. Okay? Well, here, on the second example, again, this is like 2 times x to the negative second times y to the negative third. So anything with negative exponents, we make the reciprocal and make it a positive exponent. Well, the 2 is going to stay. So it's like 2 over 1 times x to the negative second becomes 1 over x squared times, and y to the negative third is 1 over y to the third. And we're going to just multiply those all together. So on top we've got 2 times 1, which is 2. And on bottom we've got 1 times x squared times y cubed, which is just x squared y cubed. And there's no simplifying this answer, so I am done. Alright, let's go on to some more examples. Okay, for this example we're going to talk about 2 different ways to do this. Okay, first one that I'm going to show you is, remember if we did the exponent rules, I'm taking my base is 5 times a. So again, that multiplication exponent rule says when I'm multiplying two things together for a base, that I can apply the exponent to both of them. So really this is the same as 5 to the negative second, a to the negative second. Okay, so what that will become when I want to rewrite with positive exponents is 1 over 5 squared times 1 over a squared, which is the same as just 1 over 5 squared times a squared. Okay, that's one way to do this one. Another way is to think of this just as all one thing. Like, think this is a big x. If it was x to the negative second, I would just make it the reciprocal and make this a positive exponent. So another way to do this is to say this is the same as 1 over 5a to the second power. And again, I wouldn't want you to leave that, okay, so we would make it 1 over 5 squared a squared. Okay? And if it told you to completely simplify, then of course we'd make it 1 over 25a squared. Well, this one here, my exponent is a negative 3n, so all I need to do is make it the reciprocal of this, which means I'm basically just going to take this fraction and flip it over and make the exponent positive. So this is going to equal d to the positive 3n over 1, or just d to the 3n. Right, and we got one more slide of examples. Alright, now we're kind of mixing our negative exponents and positive exponents and how to go about doing these, okay? Well, on a problem like this one, there are multiple, problem like this one, there are multiple ways to do this. Okay, I could start by changing this, okay, to 1 over 3 squared and then multiplying it, but I don't have to do that, okay, because this is the multiplication rule. Remember, the multiplication rule states that when we're multiplying things with the same base, we're going to keep the base the same and then add the exponents. So it's the same as 3 to the negative 2 plus 2. Well, that is the same as 3 to the negative 2 plus 2 is 0, which is the same as 1. Okay? This is the power of a power property. Remember, for power of a power property, we first want to multiply the exponents together. So this is the same as 2 to the negative 3 times negative 2 power, or 2 to the positive 6 power. And that's it. Okay, now for this one, again, power of power property. This is going to be 2 to the negative 3 times positive 2 power, which is 2 to the negative 6. And we cannot leave this with negative exponents, so I need to rewrite this as 1 over 2 to the 6 power. And that is it. Okay, now your book, I can't remember because I haven't looked at this yet, it might take this and multiply it all out and say 2 to the 6 is 64, and this is 1 over 64. I want you to leave your answers, when it says evaluate, as exponential, okay, in exponential form, so that they stay like this. Okay, same thing here, I guess we could have left this one as 3 to the 0 as well, and I would have counted that right. Alright, so that's your lesson on 0 and negative exponents. Alright, best of luck on your homework.